Today we're going to review what we looked at yesterday, sector, segment, and annulus of a circle, and practice problems involving each of these types of circles. So the warm-up, draw a picture of a sector, a segment, and an annulus of a circle. All right, first is a sector of a circle, and when you think of sector, think of a slice of pizza. So here's our sector. And a sector, again, think of a slice of pizza. So from the center, sorry, my phone keeps ringing. All right, so here is, if that's the center of the circle, this is a sector, piece of pizza. A segment of a circle, so segment I'll do down here. A segment would be, if you think of just taking a knife and cutting somewhere across the pizza, so this would be an example of a segment of a pizza. So it doesn't have to be through the middle. In an annulus of a circle, think donut, flat donut. So if I draw this right here, think of a washer, if you know what a washer is, but you play the game washers. Again, flat donut, so there's an annulus of a circle. Okay, to get the area of each, the area of a sector of a circle is your angle over 360. So I'll put n for the angle in degrees over 360 times the area of a circle. So your angle over 360 times the area of a circle. The area of a segment of a circle, think your slice of pizza, so the segment of the circle minus the area of the triangle. So it's that same formula from above, n over 360 times pi r squared, but you're going to subtract the area of the triangle. And here's the triangle with your base and your height. So it's going to be base times height divided by 2. Okay, and that'll give you the shaded region. An annulus of a circle, area of the annulus of a circle, I'm going to write over here underneath it, but it's just the area of the big circle, so pi r squared, that's the big circle, minus the small circle. Okay, so those are your 3 area formulas that we looked at yesterday, we practiced yesterday, and we're going to practice again today. So we're just going to do a few examples, and you're going to practice again these on your assignment. So the first example, let's say a car's window wiper of length 20 inches goes through an angle of 160 degrees. Work out the area of the window covered by the window wiper and draw a picture. So again, if I do, here's 180 degrees. But your window wiper only goes through 160 degrees. So it goes back and forth from here to here. Okay, so again, this is our 160 degrees. This would be our 20 degrees then. All right, and then if I just draw this, this is part of a circle that it makes. You can see that we're looking at this part of the circle. So you have to think, when you're doing problems like this, do you have a sector, a segment, or an annulus? In this, if we drew our whole circle, and this was the center, which I didn't make a very good picture, this would be our sector. So this is a sector. And again, we know that that is our angle over 360 times pi times the radius squared. Here the radius is 20. So you can type that in your calculator. Again, you might want to use parentheses around each of these parts. And your answer is about 558.5 inches squared. So that would be the area of this sector of the circle. So again, draw a picture if it's not drawn for you. Figure out which formula you need. Sorry again. And then solve. So this one, find the shaded area if the big radius is 12 and the little radius is 9, and it's part of an annulus. So this one right here, let's, number 1, figure out the area of the whole annulus, and then we're going to figure out what part of the annulus we have. So this one right here, our strategy is our big circle minus the little circle. Let's do that first, and that'll give us the annulus. Let's spell a little right. Okay, so this would be pi times 12 squared minus pi times 9 squared. And if you do that, we get about 197.92. So there's the full area, the full flat donut, or annulus. But step 2, we only have part of the annulus, so we have to figure out what part we have. And if we have a circle, it's 360 minus 60. That would be, we would have 300 degrees of the circle. So 300 divided by 360, that's what part of the circle we have. We're going to multiply that by the area we figured out above. So it's going to be 300 out of the 360 times the 197.92, and that area is about 164.93 centimeters squared. So again, you figure out the whole area, and then what part, what fraction of the area do we have, we'll multiply that, and we'll get 164.93. And that makes sense, it's less than the whole area. And then number 3, clear this off. The area of the shaded area is 10 pi centimeters squared. The radius of the circle is 10, and the radius of the small circle is 8. Find x. And x would be just the shaded part. Well, actually, x would just be the sector right here. I'm assuming. Let me double check. I apologize. My phone keeps ringing. Okay, so let's see. So this one right here, to find the shaded area, the shaded, which we know, let me erase this. The shaded, which we know, is x over 360, that part of the circle, times, like we did in the previous problem, the big circle minus the small. So that's how we can get the area. It's the fraction of the big circle minus the small circle area. And here we know the area. The area is 10 pi. And we don't know the angle. So here we're solving for the angle. So that equals x over 360. So there's the angle. And then we have our big area minus our small. And in the big circle, it's pi times 10 squared. And in the small circle, it's pi times 8 squared. So plug in everything that we know, and we're going to solve for x. So if we simplify here, if you notice, I'm going to rewrite this. 10 pi equals x over 360. And this, I'm going to pull the pi out. There's pi in each of these. I'm going to pull the pi out, and we'll have our 10 squared minus 8 squared. And if there's a pi on each side, and I divide the pi out, I'm just going to cancel that. So now we have 10 equals x over 360 times 100 minus 64. So that would give us 36. And to solve for x, we could multiply each side by 360 to get rid of this here. So we get 3600 equals 36 times x, and last step, divide by 36. So here we get x. X would be 100 degrees. So this is applying that formula and using algebra to solve for the missing side. Okay. 2 left that we'll try. Find the area of the shaded circle. So this, the strategy for this, the shaded area equals area of the big sector, or area of the, let's see, area of the big sector plus area of the triangle. So the big sector is this part right here. There's the big sector. Plus, we're adding the area of the triangle. That's our goal. That'll be the area of the shaded region. So we plug in the area of the big sector is, if this is 90, we could figure this out. 360 minus 90 will give us 270. So we have 270 out of 360 degrees times pi times 18 squared, because 18 was the radius, plus the area of the triangle, which is base times height, 18 times 18, divided by 2. So let's do these two parts separately, and when you type them in the calculator, if you did it correctly, you'll get 925.41, and this was in feet, and it's area, so feet squared. All right, last one we'll try together, and you just have a bunch of application problems. It says the American Institute of Baking suggests a technique for cutting and serving a tiered cake. The layers of cake have the same height and the radii 8 inches and 13 inches. The top tier and the cake directly under it are cut into 8 wedges as shown. The outer ring of the 13-inch tier is cut into 12 pieces. Which would be larger, a piece from the top or a piece from the outer ring? Explain. Okay, so let's figure out two things here. The top first. The top would be the area of the sector. And the area of the sector, we're going to take 360 divided by 8. So each of those is 45 degrees. So that would be 45 over 360. So here's area now. Times pi times 8 squared. And that area would be about 25.13 inches squared. Okay, so that is the area of one of the top slices. Now we need the area of just one of the sectors right here. And to do that, it is just going to be the big, so the annulus, the big minus the small. And then it's cut into 12 pieces, so divide by 12. So again, it's the big circle minus the small circle, you get the annulus, but then it's cut into 12 pieces, and you just want one of the pieces. So that's why we divide by 12. So this one, the strategy, I'm running out of room, so I'm going to do it up top here, is pi times 13 squared minus pi times 8 squared divided by 12, and those are 27.49 inches squared. So actually the area on top of the outer ring is bigger. So your assignment will be to practice several of these problems. Draw a picture, pick your formulas, and solve.